Okay, so this is the 2023 Higher Level Applied Maths Leaving Cert paper question 9. The manager of a regional hospital decides to arrange for the refurbishment of one of the hospital wards. The diagram below shows the scheduling network for the project. The edges of the network represent the activities that have to be completed as part of the project and are labelled with the letters A to L. The duration in days of each activity is represented by the number in brackets. The unlabeled edges shown with dashed lines do not represent real activities, but they help explain the order in which the activities must happen. The letters used to label the edges should not be taken as representing the order in which the activities happen. The nodes of the network represent events or points in time during the project. The source node is the time when the project begins, and the sink node is the time when the project ends. Let's see, part 1 here we have to complete the table on the next page by listing for each activity the other activities on which it depends directly. That is, for each activity X, which is an element of A, B, C up to L, write the smallest possible list of other activities which need to be completed before activity X can begin. Use the space below to show relevant supporting work if necessary. Okay, so let's start with activities A, B, and C. So we can see here we've got A, B, and C. They're not going to depend on any other activity, so we'll just put in a dash here for these three. Now if we look at the next one, D then, A, B, C, D, so D is up here. D is just going to be dependent on A, so we put A here in the table. E then is here. That's also going to be just dependent on A. And then F, which is here. F is dependent just on C. There's only one arrow pointing into it here, so it's just going to be dependent on C. G then is here. So G is dependent on B. And it's also actually dependent on C here because of this dummy activity here. So we've got to put B and C here. H then is, where's H? H is here. Now H is dependent on F directly and indirectly on C, so I'm not going to include that because it says depends directly on, so I'll just include F here. And it's also dependent on E because we have an arrow coming down here and then we have this dummy activity coming down here, so it's dependent on E as well. And it's also dependent on G. Now G is dependent on B, but we've also already done G, so G is dependent on B and C, so we won't include those. I is here, so I is dependent on E anyway. It's also dependent on B because of this dummy activity here, so we need to put in B there. And it's also dependent on C because we have C coming down along here, we have a dummy activity here, we have a dummy activity here, so it's dependent on C as well. So I is dependent on E, B, and C. J then, J is here, so J is going to be dependent on E. J is also dependent on B because of this dummy activity here. It's going to be dependent on B. And it's also dependent on C, again because of these two dummy activities. So you have C coming down along here, then you have a dummy activity here, and then we have J up along here. So it's going to be C as well. Now K is next. K then is here. That is dependent on, because of this dummy activity, F. It's also dependent on G, again because of this dummy activity here. And it's also dependent on E, again because of this dummy activity here and this one here. It's connected to E, if you like. Okay, and we have one left, and that's L. So L is going to be dependent on D, anyway, here, and also J. So just D and J. And that's it for part 1. Okay, so let's have a look at part 2. Calculate the early time and late time for each event. Complete the diagram below by writing the early time in the upper box and the late time in the lower box at the node representing each event. Okay, so what we're going to do here is we're going to start at the source node and work our way through to the sync node and use the greater of the values. And then we're going to start at the sync node, work our way back to the source node and use the least or the lower values. I'll explain exactly what that means as we go along. So let's start at the source node anyway, and we can just put in 2 zeros here. And let's look at A. So at A here, we're going to put in 14. There's just one arrow going in here, so we're just going to put in 14 here. Now at C, there's just one arrow going into C, and that has a value of 14 along here, so we're just going to put 14 in here. Now if we look at B, we've got two arrows going in here. We've got one from B and one from C using this dummy activity here. So we have 12 along here, so we could put 12 in here. But if we come down along this way, we've got 14, and then up here it will still be 14 because this has a value of 0. So the largest of 12 and 14 is 14, so we'll put 14 in here. Okay, so let's look at, what have we done, A, B, C. Let's look at D then. So at D there are two arrows going into D, so we have 14 plus 12, so that's 26. But if we come down along this way, we have 14 plus 5, which is 19. 19 plus 11 is 30, so 30 is the larger one, so we're going to put 30 in here. Okay, let's have a look down along here at E. We've got two arrows going in there, so let's see, we've got 14 plus 5, which is 19. Or we just have, in this direction here, we just have 14. The larger one is 19, so we'll put 19 in here. Let's have a look at, what are we on? E, so let's have a look at F. Here we've got two arrows coming into this node here. So we have 14 plus 4, which is 18. Or we have 14 plus 3, which is 17. But actually we've also got this dummy activity here as well. So we can come along here and go into G. There's actually a value of 19 coming in this direction. So we're going to use the 19, that's the larger of the three. Okay, so let's look at this one down here next, let's say. So this is has one arrow going into it. It is 19, so we're just going to put 19 in here. And then finally we're at our sync node. So let's see what's the largest number we can put in here. We've got 30 plus 2, which is 32. So we can use 32. We can use, let's see, 19 plus 11. So that's 30, so that's lower. We're not going to use that one. We've got 19 plus 12, which is 31. So we can't use that one either. And we have 19 plus 13. So that's 32. So the largest number then is just going to be 32. We'll put that in there. Okay, so now we've got to look at the late times. To do that, we're going to look at the least values working backwards. So let's have a look at this one up here first, let's say. So we have 32, and what we've got to do is subtract 2. So 32 subtract 2 will give us 30. So we're going to put 30 in here. Let's look at this one down here. We've got 32 minus 13. That's 19, so we can put 19 in here. Let's have a look at this one here. Now we have 32 minus 11, which is 21. We also have this one here as well, so we've got 30 minus 11, which is 19. The least of these two here is 19, so we can put 19 in here. Okay, so let's have a look at this one here. Now we have, by the way, I should really put 32 in here as well. So we have 32 here minus 12, which is 20. We also have 19 here minus 0, which is 19. So we can use 19. And we have also got 19 minus 0 here, which is 19. So the least of all those three anyway is 19. So we can put a 19 in there. Okay, let's have a look at this one up here. We have two arrows coming out of this node. So here we take 30, we subtract 12, and we get 18. We have 19 minus 5, which is 14. So the least of those is 14, so we can put 14 in here. Okay, let's look at this one. We have two nodes here coming, or two arrows, two paths, if you like, coming away from this particular node here. So we have, let's see, 19 minus 0, so that's 19. We have 19 here minus 3, which is 16. So the least of those is 16, so we can put 16 in here. This one down here now, we have two arrows coming out of this particular node. So let's see, we have 19 minus 4, so that's 15. And then we have 16 minus 0, which is 16. So 15 is smaller, so we put 15 in here. And that's really it. That's all our nodes filled in, our early and late times. Okay, so let's have a look at part 3, write down the critical paths for the network. So the critical paths are going to involve the nodes with the same early and late times. So we're looking at from up along here, along A, down to E, up along to J, or along J, and then down along L to the sync node. That's one anyway. We have another one here where we can go from up along A down to E, and then you've got a dummy activity here, and K as well. So we've got A, E, K, and we've got A, E, J, L. There are two critical paths that we can use. So we've got A, E, J, L. And we also have A, E, and K with two sync nodes there. Okay, so let's have a look at part 4. A cascade chart or a Gantt chart is a type of bar chart which may be used to represent a project schedule. The duration of each activity is represented by the width of the horizontal bar for that activity with time on the horizontal axis. The float time for an activity is represented by a rectangle drawn using dotted lines to the right of the bar for that activity. The top row of the cascade chart is used for a critical path. Draw a cascade chart or similar bar chart to represent the schedule for this project. So the way you start these is to look at a critical path and draw that one first. So I'm going to do AEJL, and they are in days. So if you look at A, for example, A here takes 14 days, E takes, let's see, 5 days, and J then takes 11 days, and L takes 2 days. So we've got to represent those ones first. Let's start with A. A we're going to put here, and that goes out to 14. So you can use a ruler doing this. I'm doing it freehand, so it's going to be a little bit shaky, but we have to go out to here, down, and across. There's A anyway. So that took 14 days. We're now going to look at E. That takes 5 days, so we've got to go out to 1, 2, 3, 4, 5. So we're going down here and back. So that's 5 days. That's E. And then J, that takes, let's see, J takes 11 days. So we've got to go out 11 squares. So let's see, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then up, across, so this is J, and then finally we have 2 days for L, and that's our critical path. Okay, so we started with A. Let's do B next. So B, if we look at B here, it takes 12 days and starts at 0 as well. So you've got to go out to 12 for B. So we're going to go out to 12, down, across. So this is B. and it has a float as well, which we've got to look at. B has a float. We've got to work out our float values as well. So let's write our float times here. So we start with A. A is just going to have a float time of 14 minus 14 minus 0. So let's look at B, which is what we're looking at the moment. So the way you work out the float time here, it's going to be this value here, this 16. So the late time for this node minus the duration of B, which is 12, minus the early time here, which is 0. So the float time for A is 0. So for B, the float time is going to be 4. So we've got to draw that in on our Gantt chart. So it has a float time of 4. So we've got to draw dotted lines 1, 2, 3, 4. That represents the float time for B. Okay, let's do C next. So C, again, here we'll need to start at 0, and it has a duration time of 14 days. So we've got to go out to 14. Going to be out to, let's see, that's 12, 13, 14 is here. That's C, and we've got to work out its float time. So if we come up here and have a look at our float times, we have C. So C is here, so we take this value here, the late time here, which is 15, subtract 14, so it's 15 minus 14, and then this value here, the early time here, which is 0, so it has a float time of 1. So we just have to draw in dotted lines here for 1 day. Okay, so that's A, B, C, and we need D next. So let's have a look at D. We see that D will start on day 14, so that's where we need to start, and it has a duration of 12 days. So we start at 14 and go out 12 squares. Let's draw that in. So we're starting here, and we're going out 12 squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Out here to 26. This is D. Now we just need to work out D's float time. So D's float time then is going to be this value here, the late time here, which is 30. We've got to subtract D's duration, which is 12 days. And then we've got to subtract this value here, which is 14, the early time there. So when you do that, you will get a float time of 4. So D has a float time of 4 days. So let's draw that in. So 1, 2, 3, 4. That's D done. So we have A, B, C, D. We have E already, so let's go for F. So when does F start? Well, F is here, and that starts on day 14 and has a duration of 4 days. So 14 out to 4. Let's do that one. So 14 is here again. I'm going to go 4 squares. 1, 2, 3, 4. This is F, and its float time. We can work out. Let's see, we've got F here. So F, we take the 19, we subtract 4, which was its duration, and then subtract 14, the early time here. 14, so we're subtracting 18 from 19, which is 1. So F has a float time of 1 day. Okay, so let's do G next. So G starts on day 14 as well, so that starts, this is G here, starts on day 14. And it has a duration of 3 days. So 14 and then 3 squares for G. It's G, its float time then. So G is here, so we take the late time here, which is 19. We subtract its duration, which is 3. And the early time here at this node, at its start node, which is 14. That gives us a float time of 2. So let's draw that in. Okay, so let's see, we have A, B, C, D, E, F, G. We next need H. So let's see where H starts. So H is here, and that starts on day 19 and has a duration of 12 days. So 19 out to 12. This is H. So let's work out H's float time. So H is here, so we take the late time here, so which is 32, we subtract the duration, which is 12, and we subtract 19. So that gives us a float time of 1. Okay, so we just need to put in 1 here, 1 in dotted lines out here. Okay, so next one then, we've got H, so next one is I, so let's see where that starts. So I is here, that starts on day 19 as well, so let's start there. That has a duration of 11, so we start at 19 and we go out 11 squares. So 19 and 11 squares, so it's going to be the same as this one. This is I, and it's float time. So I is here, so we take 32 minus 11 minus 19. 32 minus 11 minus 19, which is 2. So I has a float time of 2. Okay, J we've already done, so we just need K. So K is here, starts on day 19 as well, and has a duration of 13. So 19 out to 13. This is K. And its float time is going to be, so K we start at 32, we subtract 13, and then we subtract 19. And we should get 0, which we do. So that is it then. I think we have all of them, A, B, C, D, E, F, G, H, I, J, K, up as far as L. And that's it. That's it for this part of the question anyway. Okay, so let's look at the last part of this question. The hospital manager visits the project on day 18 to check the progress of the work which is on schedule. Write down the activities which may be happening on day 18. Okay, so if we look at day 18, day 18 is here. You just draw a line down along here. This is day 18. So which may be happening on day 18? Well, we've got E has to be happening anyway, D is happening, F can be happening, and G can be happening as well. Remember, F could be finishing here, but F could have been pushed out 1 day because of this flow time here. G could have been pushed out 2 days here because it has a 2-day flow time. So our answer here would be E, D, F, and G. E, D, F, and G. And that's it for this question.